In today's video, we will be talking about electromagnetism. After watching this video, you should be able to define what electromagnetism is and be able to properly use what's called the right-hand rule in terms of determining what direction the magnetic field is pointing around a current-carrying wire. So let's get right to it. Electromagnetism was actually first discovered by a Danish physicist named Hans Christian Ørsted. And I'm not positive that's exactly how you pronounce his last name, but I'm hoping for the best on that one. And basically this guy, he found that a current running through a wire actually creates a magnetic field surrounding the wire. And so this discovery caused basically the kickoff of the study of electromagnetism. Right, so a current running through a wire actually creates a magnetic field, which is pretty interesting to think about. So what is electromagnetism? The answer is that moving electric charges will create a magnetic field, and this is typically noted with the letter B. This B stands for the magnetic field. Okay, why they pick B, I don't know. I think they're starting to run out of letters in terms of naming things, but typically this is called the B field, which is the magnetic field. And as I said, a current running through a wire or moving through a wire creates a magnetic field. So if you look outside at a power line, the current that's running through those wires actually is creating a magnetic field that spirals around the wire. You can verify this by placing a compass near a current-carrying wire, and actually the compass needle will line up with the magnetic field. Okay, so the compass needle will no longer actually point north. It will line up with the magnetic field being created by the current running through the wire. This also leads into kind of some cool applications that you can use with electromagnetism. You can create something called an electromagnet, and basically if you coil a wire around an iron rod, the B field spirals around this rod and makes the rod magnetic. The more wires that you wrap around the rod equals more magnetic flux, and so you have a stronger magnet. And what's really cool about electromagnets is you can actually turn them on and off, which is not typical with like a normal permanent magnet. So this is why they use these at like junkyards and that type of thing to pick up like huge cars and that type of deal. You can turn the magnet on, lift the car up, move it to where you want it to go, and then turn the magnet off and the car falls off the magnet. So basically you have a wire that's coiling around a rod, and it creates a magnetic field and really creates a powerful magnet. And this is just the power supply, whether it's a battery, an outlet, whatever the case may be. So passing electricity through a wire creates a magnetic field around the wire, and basically this picture, although it looks maybe a little confusing at first, the current is running from the bottom of the page to the top of the page, and these are compasses at various points around the wire. And you'll notice the needle points a different direction at different spots around this wire, indicating the direction of the magnetic field. So this is what is really important for us to understand. This is something that you need to know for the final exam. Okay, so this is something that's an important concept. It's called the right-hand rule. And there's actually in your book, I believe, 3 different right-hand rules. We really only need to know this one. And since we're just short on time, this is what we're really going to focus in on, is just this first right-hand rule. There's a lot of different ways that you can do the right-hand rule, and your book actually is a little bit different than the way I'm going to explain to you, but in my experience this is the easiest one to do because it causes for the least amount of mistakes to happen. So what you do is your thumb of your right hand, hence the name right-hand rule, points in the direction of the current, which a lot of times is I. All right, current is typically I. If you remember from Ohm's law, current is I. The thumb of your right hand points in the direction of the current, and the finger pads of your hand, which if we look at this picture, here are the dude's finger pads right here. The finger pads point in the direction of the B field, which again, what is the B field? That is the magnetic field. And I'm going to do a practice problem with you right now, or not right now, but in the next slide. showing you how the right-hand rule works. Okay. Before I do this practice problem, I want to kind of talk about some annotation, if you will, on the right-hand rule, or on magnetic fields. If you have to imagine this is three-dimensional, and so it's hard to make a two-dimensional piece of paper or video screen, whatever you're watching this on, three-dimensional. So to show that the B field or the magnetic field may be going into the page or into the screen or whatever you're watching, we in physics use this type of annotation where it's an X and there's a circle around it. This is into the page. Okay, and the way to kind of remember this is like if someone shot an arrow and the arrow was flying away from you, you would see just the tail feathers of the arrow. Now, if it's coming out of the page, it's just a dot, and that is out of the page. And again, going with the arrow idea, if an arrow is coming at you, you would just see the tip of the arrow on its way traveling towards you, and so that is out of the page. Okay, so it says for our practice problem, identify the B field above and below the wire. So the current is running from left to right. It's going this direction. And so I encourage you to try this right now. You're going to look a little weird if you're in front of a computer screen doing this with your hands. But make your thumb point in the same direction as this arrow, the right hand of your thumb, point in the same direction as this arrow. And I am far from an artist. But if I do that, here is my thumb. And like here's my fingernail, and then there's like those wrinkles there. Here's my thumb, and then my hand looks something like this. And like I said, I apologize. This is pretty ugly. Okay, so my thumb is right here, and it's pointing from left to right on this line. And then here are my fingernails. Okay, and what direction are my finger pads pointing right now? They would be pointing into the page, into the page. And so the B field on the bottom part of this wire would be into the page. Now you may say to yourself, well, what about on top of the wire? What about on top of the wire? Again, if I draw my hand, my thumb would be going this direction, except this time notice there's no nail that I'm going to draw on it because the nail couldn't be seeing it at this point. And then here are my fingers. And again, no nails on my fingers because they're on the side that you can't see right now. But here it is. And here are my finger pads, okay? Notice my finger pads are pointing right at us. And so the B field would be coming out of the page. Okay, and so I'm just draw those out of the page. All right, and then we could do like, you know, basically like into the page and out of the page, what direction would the B field be pointing and all that stuff. But I think these two are the two easiest examples where if you put your thumb in the direction of that the current is traveling, and your finger pads will tell you the direction of the magnetic field. This is something you're going to have to be able to do for the final exam. So it's worth practicing, and in the review packet it's worth practicing. And if you're still confused, please come and see me so we can make sure that you know how to use the right hand rule, and that's what this is called. So here's just another example of the current running through a wire. Current is typically represented by an I, and you can practice it right now. What direction would the B field be on the right side of this wire? Well, my thumb would be pointing up, and my finger pads would be pointing into the page. Okay, so the B field on the right hand side of this wire would be into the page. What about on this side? Well, swing your hand around and have your thumb still pointing up, and notice your finger pads are pointing out of the screen. So we would have a B field coming out of the screen. Okay, so this is the big thing that you guys learn in this lesson, is how to do the right hand rule for a current carrying wire. That takes care of this video. I will see you guys next time.